Okay, next couple examples are going to look at explosion types of events. So here we have a 1 kilogram firecracker that explodes into two fragments. The first fragment has a mass of 0.4 kilograms and is moving to the right at 32 meters per second. What is the velocity of the other piece? So if we take a look here at our firecracker, after it explodes, you get one piece of the firecracker is going to go to the left, and you have one piece that's going to go to the right. Now the piece that goes to the right, you're told, has a mass of 0.4 and 32 meters per second. Now over here, you weren't told directly the mass of the other piece of the firecracker, but if it's 1 kilogram in total, the mass is still maintained. So if you start with 1 kilogram, the other piece weighs 0.4, your second piece has to weigh 0.6 kilograms. And you had to find its mass. Oh, sorry, its velocity after. And you should always write out what's given first. So we know the mass of the combined piece, or firecracker, is 1 kilogram. Mass of one piece is 0.4. Its velocity is 32. Mass of the second piece is 0.6. And its velocity after the explosion we don't know. Again, which piece you decide to call A and B doesn't really matter. Just stay consistent when you go with it. So when you start here, again, we always start with momentum before equals momentum after. So momentum of the whole piece is equal to momentum of each separate piece after the explosion. And momentum, remember, is mass times velocity. So the mass of the firecracker originally is 1 kilogram. It wasn't moving, so its momentum before is going to be 0. The second piece, 0.4 kilograms, moving at 32 meters per second. The other piece, 0.6 kilograms, and we don't know its velocity. So now we just work out the math. 12.8 times 0.6, we're going to move our 12.8 over and divide by 0.6. And we find that you get negative 21.33 meters per second, or 21.33 meters per second to the left because of the negative. And if we want to get it down to scientific notation, 21 meters per second to the left. Alright, just so that doesn't distract you. There is a quicker way to look at explosions. In explosions, if both objects are at rest, their velocity is 0. The total momentum before the explosion will be 0. And the momentum of one piece will have the same but opposite direction to the other piece. So, again, the condition on this, if both objects are at rest and their velocity is 0. So we look here from the last example. Momentum before, again, is momentum after. We'll find the momentum of the fragment that goes to the left and the momentum of the piece that goes to the right. So momentum of the left piece, momentum of the right piece. We'll move down through. Momentum of the piece going to the left, we know its mass was 0.6. Now I just look back again. We know the mass of the second piece was 0.6, so we figured that out. That's nothing new. We didn't know its velocity. The piece that was moving to the right, we were told moves at 32 meters per second, and its mass is 0.4. So if you work this out, you get 21 meters per second to the left. Now, our negatives wouldn't have worked out here. You don't see any negative signs. But what you have to keep in mind is that we did say it was going to be negative. Right here. Highlighter. So So we did say that it was going to be moving to the left. So although no negative signs worked out there, we did know that in the beginning. So be careful of that answer. Don't write velocity left and then say, oh, well, that's a positive answer, and you put right in brackets. Pay attention to what you're doing. And that's a simple mistake to make. Alright, next example. And just take this out of the way. So a toy gun shoots a 50-gram ball with a speed of 5 meters per second to the right. If the gun has a mass of 200 grams, what's the recoil velocity? So you could think of a Nerf gun. And you could have one of these Nerf guns, and it shoots a foam ball or a dart to the right, and it weighs 50 grams. Remember that needs to get converted to kilograms, so you divide by 1,000. And it's moving at 5 meters per second. What we want to know, what's the recoil velocity of the gun? And the gun itself weighs 200 grams. In kilograms, 0.2. So what we're given, I didn't state it out there. We have the mass of the ball. Well, let's use our notation here. We know this is moving to the right. So the ball is moving to the right, and it weighs 0.05 kilograms. The velocity of the object moving to the right is 5 meters per second. Mass of the object to the left, which is our gun. Think left and right. The gun's on the left side. We're told is 0.2 kilograms. And we don't know its velocity. And we have to find that. And again, this is an explosion type. The objects are separating apart. So momentum before is momentum after. So momentum of the left equals momentum on the right. So your mass times your velocity on the left, 0.2 times velocity on the left. Mass of the ball times velocity of the ball. And now just solve your math. You get 0.25, so divide by 0.2. And you get 1.25 meters per second to the left. Or in scientific notation, sorry, not scientific notation, significant digits. And I may have said that earlier. I meant to say significant digits. 1.3 meters per second to the left.